Okay, so now let us look at this problem. G of x equals x times square root of 2 minus x squared. We have two questions. The first one is find the open intervals on which the function is increasing and decreasing, and two, identify the function's local and absolute extreme values, if any. Okay, so first, so first question, find the open intervals for increasing, decreasing. Okay, that's questions to find local and absolute extreme values. Okay, if any. So those are two problems. So before we start to figure out the interval and then local and absolute extreme values, you know that we're going to always need to take the derivative of the given function. However, for this problem, realizing that the domain of this function is not all real numbers. Instead, as you can see, it has square root of 2 minus x squared. So based on the property of a square root, you do need to make sure that, so the domain of the function, you need to make sure that 2 minus x squared actually is going to be greater or equal than 0. Okay, that is x squared must less or equal than 2. That is also is x is between negative square root of 2 to square root of 2. Okay, so if we write the domain in the interval notation, that's going to be from negative square root of 2 to square root of 2. So this is our playground. You know, everything is based on the domain of the scalar function. Okay, so that's the first step. Now we go back to talk about how do we figure out the open intervals for increase or decrease. Well, first of all, let's take the derivative to see if we can find the critical point. So g of x is x times square root of 2 minus x squared. And also, you know, to help us simplify the derivative process, I'd like to rewrite into this way. So g prime equals, we're going to apply the product rule first. Okay, so 2 minus x squared to the power half, and plus x times okay, so that's product rule. That is 2 minus x squared to the power half, because the derivative of x is 1, and then plus x. For this, you're going to apply the, what we call the chain rule, right? So that is half 2 minus x squared to the power of negative half, and then times the derivative of this inside, which is negative 2x. Okay, negative 2x. So that's what we get. So for here, so you can see, first of all, you have a 2, 1 over 2, you have a 2x, and then you have negative, so you have x and x. So in other words, if we can simplify a little bit, we're going to have a minus, because there is a negative here, x times x is x squared, half times 2 becomes 1, 2 minus x squared to the power of negative half. Okay, so that's what we have it so far. And of course, if you want to reorganize this a little bit, noticing that because 2 minus x squared to the power of negative half equals 1 over 2 minus x squared to the power half. And if we write that into a radical form, that's how do we write into this way? Okay, and more, if you want to combine them into one, that means, right? So, right, that those two have the same denominator. Okay, so for our first one, if you square that, that can give us 2 minus x squared. And then minus x squared. So it's 2 minus x squared over 2 minus x squared. So to the very end, that can give you 2 minus 2x squared over 2 minus x squared. Okay, so that is the derivative of the function g of x. Okay, and now let's try to figure out what is the critical point. Okay, so first, remember, find the domain, step 1. Step 2, find the derivative. We're going to apply the product rule first and the chain rule. I also need a little bit algebraic operation. This is what we get. Now, to find the critical point, remember the critical point is those values either make my derivative equal 0 or make my derivative undefined, right? So if you look at that as a critical point, if you look at the derivative, we can find that, okay, when 2 minus 2x squared equals 0, that is when the numerator equals 0, you can solve for that. That is x equals positive 1 and negative 1. Okay, so yes, those are the two critical points that will make my derivative equal 0. Wonderful. Also, don't forget that those values when 2 minus x squared equals 0, that is when your denominator equals 0. And then you solve for that x equals positive square root of 2 and negative square root of 2. Those two values will make my derivative undefined. So those are also critical points. So in this problem, actually, we have 4 critical points, okay? 4 critical points. All right, so now let's draw this real number line. Label the left end point of my interval is square root of 2, right? It's negative square root of 2 and positive square root of 2. Now look back those critical points. You see, actually those are my end point for my domain, right? So that's perfectly good. And then we label negative 1 here, we label 1 here. In fact, when we go back to the first part of the question, it asks us to figure out the open intervals for increasing or decreasing, right? So along with what we have so far, actually we need to determine the 3 intervals part. That is from negative square root of 2 to negative 1, and then from negative 1 to 1, and then from 1 to square root of 2. Okay, we need to determine those 3 intervals, either increasing, decreasing, or increasing. Okay, so that's our work for the first problem. Okay, so let's use a new paper and then continue. So usually what I like to do is I like to write list a table, right? So negative square root of 2 to negative 1, okay. And then negative 1 to 1, okay. And then 1 to square root of 2, okay. So see x for this part, then you, so it's a sine of f prime of x. Okay, so for here, guys, the second row, remember we can randomly select number from each interval, and then we evaluate at the first derivative. Then we determine what's the sign of it. Okay, so let me also write it. Here, the derivative of this function is 2 minus 2x squared over 2 minus x squared. Okay, so actually, for this part, guys, before you do this, let us actually do slightly analytic thinking. So this is my derivative function, right? And then since my denominator is the square root, so this part is gonna always strictly greater than 0. Okay. So the overall sign of this derivative function actually is determined by the numerator, right? So look at my numerator. That is 2 times 1 minus x squared. So think about it this. Any number between -1 and 1, when you plug in 1 minus x squared, this part gonna be greater than 0, right? Because it's between -1 and 1. So that means overall this sign gonna be positive. Okay. Meanwhile, if you as a number which is either is greater than 1 or less than -1, then 1 minus that x squared from any of this interval, this part are going to give you a number that is less than 0. Okay, so you can see that overall the sign for this is going to be negative. Okay, it's going to be negative. So that's the analytic work. We just do the analysis. Of course, you definitely can take a random number and then to plug in to do that. So that definitely works. But I just want to show you for this specific problem, especially the structure of the first derivative, it's pretty easy to determine that. Okay, so that being said, our increasing open interval will be from -1 to 1. Okay, our decreasing open interval will be negative square root of 1 to negative square root of 2 to -1, and then union 1 to square root of 2. Okay. So that actually complete our first question. Let me go back to here, right? Figure out the open interval for increasing, decreasing. Okay. So now the next one is, okay, find the local and absolute extreme values. I mean, if that. Okay. What are we trying to do at this stage? As you can see that this at the point -1, so you have decreasing and increasing, right? So based on, so part 2, so based on the first derivative test, we can get at x equals -1, since it's, you see, since it's decreasing and increasing, right? So we're going to have a relative minimum, okay? Relative minimum. While at x equals 1, so you can see it's increasing and then decreasing, you're going to occur a relative max, relative max. Of course, what's the corresponding value of this? F of -1 is -1 times square root of 2 minus -1 squared. This part is going to give you its 1, so it's -1. While f of 1, it's 1 times square root of 2 minus 1 squared is going to give you is positive 1 here. Okay, so about the relative extreme amount, done. Okay, done. And then lastly, we're trying to figure out, okay, what is the absolute? So what is the absolute extreme values, right? So that's the last part. Okay, what we'll do is, remember, list all the critical points and all the end points. But luckily, we know that. Okay, so and then the corresponding f value, right? The corresponding f value. So you can see that f of negative square root 2 it equals negative square root 2 times square root of 2 minus negative square root of 2 squared. So in this part, it's going to give you 2. So 2 minus 2 becomes 0. So this is 0. Okay. F square root of 2, also, you can see it's a square root of 2 times 2 minus square root of 2 squared. It also gives you, it's a 0. So the corresponding value, what do we hear? It's a 0, 0. This is negative 1. This is positive 1. So you can see that the absolute extreme value, we can get the absolute max happens at x equals 1, right? And then the absolute mean happens at x equals negative 1. And then we finish the problem. Okay, so hope you enjoyed this video, and thank you for the watching.